Hey everyone, welcome back to the APIGURU channel. If you're new here, I'm Damien Thurn here, and on this channel we cover everything you need to know about APIs, integrations and modern API management. In today's video, I'll show you how Google Apigee is evolving into an AI gateway, enabling organizations to securely connect AI agents with enterprise systems. We'll explore the latest AI capabilities in Apigee, including model armor, semantic caching, and native support for the model context protocol, and see how they help organizations operationalize AI securely, efficiently, and at the enterprise scale. Artificial intelligence has quickly become one of the highest priorities for organizations around the world. Over the past year, the conversation has shifted from simple chatbots to intelligent AI agents capable of reasoning, making decisions, and performing business tasks autonomously. But here's an important point that is often overlooked. There is no enterprise AI without APIs. Every AI agent needs access to enterprise systems, business processes, and organizational data. Whether it's retrieving customer information, processing an order, approving a loan, or booking an appointment, those interactions almost always happen through APIs. That's why API teams are suddenly at the center of enterprise AI initiatives. APIs are no longer just integration technology, they have become the bridge between AI and the enterprise. Many organizations follow a very similar journey. It usually begins with experimentation. Developers connect directly to models such as Gemini, OpenAI, or Claude, and build a simple chatbot or AI assistant to demonstrate what's possible. These early prototypes are often successful. They generate excitement and prove that AI can deliver value. The next step is to make the agent useful by connecting it to enterprise applications. Instead of simply answering questions, the agent now needs to retrieve information, execute business processes, and interact with existing systems through APIs. And that's where things become significantly more challenging. Building an AI prototype is relatively easy. Running AI reliably in production is something entirely different. Once AI starts accessing enterprise systems, organizations must deal with familiar enterprise challenges such as authentication, authorization, governance, monitoring, compliance, reliability, and cost control. Without these controls, AI agents could expose sensitive information, execute unauthorized actions, consume excessive AI resources, or even create regulatory risks. Organizations therefore need a way to operationalize AI while maintaining the same governance standards they already apply to traditional APIs. This is exactly where Apigee comes into play. Rather than treating AI as a separate technology stack, Google is extending the existing Apigee API management platform with native AI capabilities. This is a very important strategic decision. Some vendors have introduced entirely new AI gateway products. Google has taken a different approach. Instead of asking customers to deploy and operate another gateway, Google enhances the platform that enterprises already trust to secure, manage, and monitor their APIs. That means existing Apigee customers can reuse everything they already rely on today. End-to-end security protects every interaction between AI applications, APIs, and the enterprise systems using capabilities such as authentication, authorization, threat protection, and traffic management. Automated CI/CD pipelines ensure AI proxies and policies can be deployed consistently and reliably across development, testing, and production environments. Built-in analytics, monitoring, and logging provide complete visibility into AI traffic, helping organizations measure usage, troubleshoot issues, optimize performance, and demonstrate compliance. Developer portals can also expose AI APIs and MCP tools, enabling developers to discover capabilities, access documentation, and onboard through a familiar self-service experience. And because these capabilities can be delivered through Apigee, organizations avoid introducing unnecessary complexity or duplicate governance for AI. Proven enterprise capabilities such as security, analytics, monitoring, and policy enforcement extend naturally to AI workloads, enabling consistent governance across both traditional APIs and AI services. One particularly powerful capability is model orchestration. Today, organizations rarely rely on a single large language model. Different models have different strengths, different costs, different response times, and different availability characteristics. Instead of embedding model selection logic into every AI application, Apigee allows this decision to be centralized. For example, a simple customer inquiry could be routed to a smaller, lower-cost model, while a complex reasoning task is automatically sent to a more capable model. If a preferred model becomes unavailable, Apigee can transparently redirect the request to an alternative provider without requiring any changes to the AI application itself. This improves resilience, reduces operational costs, avoids vendor lock-in, and allows organizations to continuously optimize their AI strategy as new models become available. Let's now look at how this works in practice. The process starts with the user entering a prompt into an AI application. The AI agent forwards that request to Apigee where enterprise policies are applied before the request reaches any language model. Apigee authenticates the request, evaluates security policies, applies routing rules, performs any required transformations, and selects the most appropriate model based on business policies. The selected large language model then generates a response and returns it to Apigee. Before that response is delivered back to the AI application, Apigee can once again apply transformations, normalize the output, enforce governance policies, and capture detailed analytics. The AI application receives a consistent response regardless of which underlying model processed the request. This architecture allows organizations to change AI providers, optimize costs, improve resilience, and enforce governance without modifying individual AI applications. And this is only the foundation. Now that we've seen how Apigee acts as the control plane for enterprise AI, let's look at the valuable AI capabilities. Let's start with model armor. Attackers may attempt prompt injection attacks, manipulate the model into revealing sensitive information, overload the service with expensive requests, or exploit vulnerabilities to increase operational costs. This is exactly where model armor comes in. Model armor acts as a security layer for every prompt entering the language model and every response leaving it. Instead of trusting every prompt, organizations can inspect, sanitize, and evaluate the request before they ever reach the model. The ideal place to integrate model armor is through Apigee. Why? Because Apigee gives you fine-grained control over what's sent to the backend and what comes back. Let's walk through the request flow. Everything begins when the user submits a prompt through the AI application. The AI agent forwards the request to Apigee. At this point, Apigee can already enforce standard API security policies such as authentication, rate limiting, or access control. If the request doesn't meet the required policies, it can be rejected immediately before consuming any AI resources. Next, Apigee invokes the sanitize user prompt policy, which sends the prompt to model armor for evaluation. Model armor analyzes the request for harmful instructions, prompt injection attempts, or sensitive information. Depending on the result, it returns either the original prompt or a sanitized version. Only then does Apigee forward the request to the selected language model. Once the model generates its response, the process happens again in reverse. Apigee invokes the sanitized model response policy and submits the response back to model armor for inspection. Sensitive information, unsafe content, or policy violations can be detected before the response reaches the user. Based on the evaluation, Apigee decides what happens next. It can return the response, block it entirely, log the event for auditing, or trigger downstream actions such as creating a ServiceNow incident for further investigation. This combination of model armor and Apigee gives organizations far more than AI security. It provides enterprise governance, visibility, and automation around every AI interaction. Let's move on with semantic caching. One of the biggest cost drivers in enterprise AI is repeatedly asking the same question. Think about an internal HR assistant. Hundreds of employees might ask about annual leave, parental leave, or expense policies every single day. The wording changes slightly, but the intent remains the same. Without semantic caching, every variation generates another expensive call to the language model. Semantic caching solves this problem. Rather than looking for an exact text match, Apigee converts each prompt into a vector representation and performs a semantic similarity search using Vertex AI. Instead of asking whether two prompts contain the same words, it determines whether they have the same meaning. Let's look at the flow. The user enters a prompt into the AI application, which forwards it to Apigee. Apigee invokes the semantic cache lookup policy. The prompt is converted into an embedding and compared against previously stored prompts using semantic search. If a sufficiently similar request already exists, Apigee performs a cache lookup. When a cached response is found, Apigee immediately returns it to the AI agent without calling the language model at all. The result is dramatically lower latency, significantly reduced inference costs, and a much faster user experience. If no similar response exists, Apigee forwards the request to the language model as normal. Once the model generates a response, Apigee invokes the semantic cache populate policy, stores the response in the cache, associates it with the semantic representation of the original prompt, and sends the response back to the AI agent. Future requests with the same intent can now reuse that response. We've now looked at how Apigee secures AI workloads with model armor and optimizes cost and performance through semantic caching. The final capability I'd like to cover is one that I believe will fundamentally change how AI agents interact with enterprise systems: the native support for the model context protocol. To understand why MCP is such an important development, let's rewind for a moment. When developers first started building AI agents, they relied on function calling. The concept was straightforward. For every API an agent needed to access, developers manually created a function that described the API operation, implemented authentication, mapped the request and the response payloads, handled errors, and transformed the result into a format the language model could understand. For a proof of concept with just 2 or 3 APIs, this approach works well. Enterprise environments, however, are very different. Large organizations typically expose hundreds or even thousands of APIs. Those APIs are constantly evolving. New operations are introduced, authentication mechanisms change, schemas are updated, and business rules evolve. Every change requires the corresponding functions to be reviewed and updated. As the number of APIs grows, keeping manually written functions in sync quickly becomes a significant maintenance burden. This is exactly the problem the Model Context Protocol, MCP, was designed to solve. The Model Context Protocol provides a standard way for AI agents to discover and interact with external tools dynamically. Rather than hard-coding every integration, agents can ask which capabilities are available, understand how to invoke them, and execute them without developers writing custom integration code for every API. MCP is like a USB-C adapter that lets AI agents plug into external tools, such as APIs. Instead of manually teaching an agent about every service, the services describe themselves in a standard format that any MCP-compatible agent can understand. Google has integrated this capability directly into Apigee. With the new MCP Discovery Proxy template, existing REST APIs can be exposed as MCP tools. Apigee automatically discovers API operations, registers them in API Hub, and makes them available for AI agents to consume. This allows organizations to leverage their existing API investments instead of rebuilding services specifically for AI. Let's walk through the request flow. The process begins when the AI agent sends a tools list request to Apigee. Apigee queries API Hub and retrieves the available MCP tools that have been registered from deployed APIs. It then returns the list of available tools to the agent, which passes that information to the language model. At this point, the model understands which business capabilities it can use, whether that's retrieving customer information, creating an order, or updating an account. Next, the user enters a prompt. Based on the prompt, the language model selects the most appropriate tool. The AI agent then sends a tools call request to Apigee. This is where Apigee performs the heavy lifting. It maps the MCP tool invocation to the underlying REST API, injects authentication credentials, applies enterprise security policies, adds any required headers, transforms the payload, and forwards the request to the target backend service. The enterprise application processes the request exactly as it would for any other API consumer and returns its HTTP response to Apigee. Apigee then performs the reverse transformation. It converts the REST response into the standard MCP JSON RPC format and returns it to the AI agent. Finally, the agent provides the result to the language model, which incorporates the information into its final response for the user. The important point is that neither the AI agent nor the language model needs to understand the implementation details of the underlying APIs. Apigee abstracts that complexity away while continuing to provide authentication, security, governance, traffic management, and observability exactly as it does for traditional API traffic. Bringing these capabilities together transforms Apigee from an API management platform into an enterprise AI gateway that enables organizations to adopt AI securely, efficiently, and at scale. Organizations can protect AI applications with the same enterprise-grade security controls they already trust for APIs, including authentication, authorization, threat protection, and model armor. Intelligent model routing and semantic caching help reduce AI inference costs while improving response times and user experience. Existing APIs, governance processes, and CI/CD pipelines can be reused to accelerate the delivery of new AI-powered solutions. Teams can apply consistent security policies, monitoring, compliance controls, and usage management across all AI applications from a single platform. Organizations can switch, combine, or optimize AI models from different providers without changing applications or AI agents. Existing enterprise APIs can be exposed as MCP tools, enabling AI agents to securely interact with backend services without rewriting existing systems. Analytics and monitoring capabilities provide visibility into API usage, AI interactions, performance, and operational behavior. By extending the existing API platform, organizations avoid introducing another AI gateway while building a flexible architecture ready for future AI innovations. The result is a secure, governed, and cost-efficient AI foundation that enables organizations to operationalize AI faster while providing a clear path to leverage existing API investments and enterprise capabilities. I hope this video has given you a practical understanding of how Google is positioning Apigee as an AI gateway and why these new capabilities matter for enterprise architecture. If you'd like to learn more about Model Context Protocol, I also have a dedicated video comparing MCP and function calling, where I explain the differences in much greater detail and demonstrate both approaches in action. If you found this video useful, please consider liking it, subscribing to the APIGURU channel, and sharing it with your colleagues. And if your organization is looking to operationalize AI securely using Apigee, feel free to get in touch through apiguru.com. Thank you for watching, and I'll see you in the next video.